Hi class, welcome to section 3.3, all about shapes of graphs. So we're going to have a little vocab to start. You will need your calculators today, so go find them, pause the video, make sure they're charged and ready to go. I'm going to do the best I can in this video, but know that when you come to class, next time I see you, we can talk about more calculator problems. Maybe you're in the wrong setting. I will problem solve everything with you in class. So don't worry, I am here for you. So a couple things about vocab. We start off turning point. That should be turning, not hurrying point. Gotta love typing, I apologize. But that is where the graph changes from rising to falling or vice versa. Maybe it was falling and then it rose. So those turning points would be like point P, point Q, point R. Notice right here it's increasing up to P, then it changes shape. So when it actually changes shape, that's called the turning point. Next vocab is if it is a maximum. Now we've talked about parabolas a good amount. Those are just the regular U-shaped curves. And we know that it's going to be either a max or min depending on what way the parabola opens. Well, the kind of graphs we're going to work on in this chapter have a little bit more to it. There's not just one curve, kind of looks like the picture. It increases, decreases a lot. So the max, we have to be very careful. It has to be the highest point. So I would go to my y-axis and look at where is it the highest. Well, that would be right here at point R. So I'm going to label this. I'm going to try to keep my colors organized. This is my maximum, my highest point in my graph. Obviously, the next part would be a minimum. The minimum has to be the lowest point. So hopefully you realize that that's point Q. This is the minimum. Ooh, no, it's not. Why is it not Q? Take a moment, think about it. Notice this little point S over here, that's the smallest. See, it happens, people. It's okay. We just have to be careful and look at our y-axes. Some of you are like, oh, Mrs. Frericks messed up there. No worries, I caught myself. Next is increasing. Any part where the graph is increasing, which means you're just upward trend. So increasing would be like this part of the graph from Q to R. That's when as you read left to right, it's going up. Hopefully then you realize decreasing is just the opposite of that. It's where it goes down as you read left to right. And those would be your decreasing points. Okay, so a lot of vocab here. Pretty much self-explanatory, but you just want to watch out for max and min. Heading down to my next area, here is your calculator work. So we took screenshots of what your calculator should look like, and we'll talk about it. So right now, on your calculator, you all need your calculators. Graph this. Go to your y equals on the top left-hand corner of your calculator. This is okay to just write y. F of x, which means a function, is just y. Make sure you type it in exactly as you see. The 4 should be in the exponent. You should use a subtraction sign, then a 3x. Do not use the negative sign. That happens to a lot of people and there's no graph. So please use a subtraction sign. This is what your graph should look like. If you're not here yet, pause. Go back to your y equals and make sure you typed it in properly. Maybe you just can't see it. Maybe this isn't what yours looks like. You can always try to go to the zoom button and hit zoom. It's number 6 called standard. that will help readjust your graph, fix your window. Maybe you were graphing something crazy last time. So zoom 6 kind of refocuses your graph and hopefully will help this shape. Now we're going to find the max or the min. In this case, hopefully it's clear to you, this point down here is going to be the min. So we're going to find the minimum in this case. So to get to this next calculator function, you need to press the button second on the top left and trace. Trace, I'll rewrite that, is on the top bar of your calculator. So you press second, trace, and all these options should pop up. Makes sense that we're finding minimum, so that's option 3. You'll click on that. Then you get these questions. It's going to say left bound question mark with a little blinky dot. And if you don't see this, pause, go back, make sure you're following every step properly. When you are choosing left bound, you can use the right and left arrows and just get to the left of your vertex point, of that minimum. As soon as you're to the left, press enter. When you do that, then a new command jumps out to you. It says right bound. Well, using the right arrow, move to the right of the point, your blinky dot to the right, press enter. Then you'll get one last command that says guess. You need to press enter here. You're helping your calculator tell you that, yeah, this is where I want you to guess. Then this will be your x, y coordinate of your minimum. Please be careful as you're doing this. If you have questions, bring them to class. But how I would write this is the minimum. When I round, I'll probably just round to 3 decimal places, so 0.909, comma negative 2.04. Next part, average rate of change. In other words, it is your slope. People always get nervous when they see average rate of change, but you don't need to. Average rate of change is just the slope. Slope has to be a straight line. Right? Slope is rise over run. Let's do an example and I think it'll make some sense. So we're using the same graph from before. We're going to find the average rate of change for the increasing parts of the fever graph. Now, I'm just going to find one part. The other part will be the same, but I'm trying to find the slope right here. I'm actually going to use my line function. Okay, this is what I'm going to find. This is the increasing portion. Remember, if you go back to the beginning, Q to R is increasing. So I want to find the average rate of change for that increasing part. Think of slope. Slope is y2 minus y1 over x2 minus x1. As long as I can find those coordinate points, I'll be able to find my slope. So let's look at this carefully. Point Q is the coordinate point 3, 100. Point R is the coordinate point 5, 103. And that's simply from looking at the x and the y of the graph. Now that I know my points, let's plug into the slope formula, which would be 103 minus 100 over 5 minus 3. I'm getting 3 over 2. So that would be my slope between Q and R, between that increasing portion. Okay, average rate of change is just slope. Let's try another one. The average rate of change of a function. Looking at this figure, the average rate of change is the slope joining the 2 points a, f of a, or in other words, x, y. Maybe I'll do x1, y1, and the point x2, y2. Right, these 2 points right here. F of a and f of b is just the y value. So if y equals f of x, that function, the average rate of change is denoted by the change in y over the change in x. Oh, that makes sense, right? I'm going to write exactly what I just said. This triangle really means change. So change in y divided by the change in x. So that's what the triangle means. It's just change. So really, rise over run. And there's my slope formula like I used above. This equals the slope. Okay, a couple examples. I'll do a couple, then I'll have you do some, and we'll call it a day. So we're going to find the average rate of change, the slope, for y equals x cubed, which is this graph to the right. I want to find from -3 to 0. So I'm finding -3. Gotta zoom in here. So here's -3. I'm going to go all the way to where it crosses to 0. As long as I can find those points, I can find the average rate of change, this line, from the point to the point. So looking at it carefully, point, let's say this is where I start. I'm going to just be super clear, peeps. Start, this is the end of my x values. So my first value was -3, comma, if I count down, I'm getting -27 to the point 0, 0. If I'm not sure what that actual point is, I could always plug into this function and see what comes out. Okay, if I'm ever unsure of what the curve, maybe where the line is, I could always whip out an XY table here. If I plug in -3, -3 to the third power is -27. If I plug in 0, 0 cubed is 0, so I know I did those points right. Just if you need. Okay, got my points. Average rate of change just means slope. I'm going to do 0 minus a -27, 0 minus a -3. I get 27 over 3. So that slope is just 9. Saved by the bell. I'm just kidding. There's still more to go. Okay? Let's do the next one. We're going from the point 0 as my x to the point 1. So that means I'm finding, start here to here. Little baby one. But that's the slope I'm finding now. So my point started at 0, 0, and I went to the point 1, 1. If I wasn't sure if that line was 1, I go to my XY table. If I plug in 1, 1 cubed is also 1. Let's find our slope. 1 minus 0 over 1 minus 0 equals 1. That would be my slope from 0 to 1. Please pause the video and you try the last one. Okay, hopefully you paused it. Your final answer should be a slope of 13. Okay, check that. Make sure you got it right. You were finding from 0, you're finding from 1 to 3, and 3 is right here. So finding the slope of this line, you should have got 13. If you didn't, make sure you ask in class or go back and look at those two examples. Last thing, my dears, you guys are doing great. This looks intimidating. Yes, it does. But I will walk you through. You're going to take your time and we're going to solve this together. What we're going to do is replace f of x with that expression, 3x squared minus 5x. So let me show you what I mean. I'll go slow. F of x, no, I'll do it this way. Sorry, guys. I'm going to look at just this portion right here. F of x plus h. That means instead of inputting an x, I'm actually inputting x plus h. Pretty big. I'm going to look at the function on the right and plug in an x plus h everywhere I see an x. So it's going to look like this. There's an x. There's an x. But I'm not just plugging in x anymore. I'm doing x plus h. X plus h. A little function notation for you. I'm going to simplify this. I'm going to get 3. I'm going to FOIL here. I'm going to distribute the negative 5. I'm now going to distribute the 3. And I'm going to look, can I combine any like terms? No, sadly I can't. So this portion right here, I'm going to plug in, I'm going to replace this, oh golly, in the original function. I know this is a lot, but take a moment. Here is my original problem. It was f of x plus h minus f of x all over h. Like that is the original problem, my dears. We're going to take what I have circled, plug it in for what it equals. You're doing a little substitution here. F of x plus h, we don't need that. We're now going to put that huge expression here. Instead of f of x, let's put what f of x actually is. It's 3x squared minus 5x. So this is what I'm starting with. This is right here. I'm now going to replace. So I'm actually just going to copy and paste because, you know, we're on lovely iPads. Gotta love technology. So that's my first portion. My second thing I'm going to put in parentheses always, is what f of x is. It's 3x squared minus 5x. That all goes over h. I'm just substituting each portion in. Now it's algebra, my loves. Let's take our time. Let's make sure we distribute properly. I'm going to get 3x squared plus 6xh plus 3h squared minus 5x minus 5h minus 3x squared plus 5x all over h. Some stuff is going to cancel. That's going to be great. I have a 3x squared and a negative 3x squared. Adios. I have a negative 5x and a 5x. Those cancel. Love it. This should happen. It should become simpler. So I'm getting 6xh plus 3h squared minus 5h all over h. I now see there's a GCF. Yes! I can take an h out. Greatest common factor. This should always happen. This should become very simpler now. Simpler now? It's my vocab today, guys. Well, look at that. I now have an h on the top and the bottom. Divide them out. They can cancel. So in the end, that really crazy thing is just going to equal 6x plus 3h minus 5. Take a look. All I did was rewrote f of x plus h, substituted both parts into the problem, and then used algebra. Don't worry, we'll do plenty more of these as we go. If you have questions, bring them to class. Good luck, my dears.